Okay, friends, we're going to take a look at the chain rule part 2 today, and let's get going. So we've looked at the power rule, product rule, quotient rule. We introduced the chain rule last time, and we're going to spend a little bit more time on the chain rule here today. And once again, reflecting on your thinking and the thinking of others will help you have a much stronger understanding of what we're doing, and also developing thinking strategies. So thinking about how to be efficient with your strategies. How do you generalize so we can make predictions, and then we can generalize, and then we can extend strategies to solve problems and puzzles. All right, so let's get in. So today, this is what we got to look at. Okay, so that's pretty tricky. Last day we were looking at just this. Last day we were looking at how do you find the derivative of that, and today we're going to look at how do you find the derivative of that times this guy here. So you can see that there's quite a bit there, and that's what we're going to take a look at. Okay, so let's just do a quick review and reminder of the chain rule. We learned last time that it would be tempting to just pull the 2 down, the power rule, but we know that when we expanded out, we noticed that there was a difference between these two, and we know this is the truth, 18x minus 6, and we learned that what was missing between those two is this guy we needed to multiply by 3, or the derivative of 3x minus 1, which is what we learned. And then we also looked at this guy here just as an observation. We noticed that the derivative of that was 6x to the 5 minus 60x squared. And when we tried the power rule and didn't multiply it by the derivative, notice that we came up short. And we came up short by about 3x squared, which is the derivative of this. So once again, the derivative is f prime of g of x times the derivative of g prime. So that's what we did. And we'll kind of sneak through this kind of, actually let's just show you the chain rule one more time. So the derivative of f of g of x is f prime of g of x times the derivative of the internal function. And you can see how these colors line up. So there's g, and the derivative of f of g of x is 2 bracket 3x minus 1 to the power 1, and then we need to multiply it by the derivative of g. I don't know that I'm going to talk about the proof real quick. So there's Newton's quotient. We can see f of g of x right there. There's y2, there's y1. And remember how we play with this is that we are going to multiply by that, that term right there, which that over that is 1, which means we're just multiplying it by 1, which makes it an equivalent fraction. Then what we're going to do is exchange those. When we do that, we notice that as h goes to 0, this is exactly equal to the derivative of g. So we can literally rewrite that sucker there as this thing times the derivative of g. And when we take a closer look at this, notice that this is actually in the form y2 minus y1 over x2 minus x1, which again is the slope formula. And if it looked like this, we'd call it f prime of x. But if x equaled g of x, so if there's a g of x there and a g of x plus h, we wouldn't say that the derivative is f prime of x. We would say that the derivative is f prime of g of x, and of course multiplied by g prime of x. So there's the chain rule. And now let's get in and look at some problems. So first things first, if we were to find, this is just warming you up. So when we're factoring that, notice that we can take a negative 3 out of both of those terms, which will leave behind a 3 and a 2. We can take out an x to the power of 4 out of each of those terms, leaving an x to the power of 1, and then no x's there. And of course, we can take y to the 4 out of each of those, leaving behind 3x minus 2. So that's sort of a warm up. This is heating up a little bit. When I see these two terms here, once again, I'm looking at the coefficient first. In the negative 9 and the 6, I can take a negative 3 out, leaving behind a 3 and a 2. And right here, I can take an x cubed plus 1 to the power of 4 out of each of those terms. So I've done that. There's to the x to the power of 4, which leaves behind an x to the 3 minus 1 to the power of 1 right there. Oops. And you'll notice right here, both of these, I can take out a x cubed minus 1 to the power of 4 out of each of those terms, leaving behind this lonely little 2. And then when I expand this all out, we're going to have 3x squared That's going to be minus 3 minus 2 is minus 5. So there you go. So this is a really important factoring skill that you're going to need to become proficient in quickly to be able to solve these derivative questions that follow. So let's take a peek at this guy. Take the derivative of this sucker. This is really going to be tricky. Just as we begin, let's be really, really careful to call this guy here F and this guy G. And there's lots of room to make silly mistakes here. There's my beautiful kiddos. There's going to be lots of room to make silly mistakes here. Let's take it, there's the answer, but let's take a look at this. So the derivative of this guy, remember, will be 7x cubed plus 2 to the power 6 multiplied by 3x squared, the derivative there. And notice that that's f prime right there. That whole blue piece is f prime. This is G, so we're going to write that down exactly as we see it. And then right here, this is F. We'll write it down exactly as we see it. And then right here, the derivative of G is going to be 6x to the power 6 plus 4 to the power 5 multiplied by the derivative of that little guy in there. Now after that, we're actually going back to that factoring question we did previously, and we're going to take out common terms. But first, what I'm going to do is I'm going to just rewrite this. I'm going to have all the sort of monomials in the front. So I'm going to put those two, the 7 and the 3x squared together, and over here I'll put the 6 and the 6x to the 5 together. So there's my 21, which came from the 7 and the 3, and this 36 came from the 6 and the 6x5. So now when we're in this phase here, now what we're going to do is we're going to see what can come out of that term and that term. So I think when we look at it, well, I guess I just put brackets there. So now what I'm going to do is I'm going to take out a 3, because a 3 will come out of the 21 and the 36, leaving me with 7 and 12. I'm going to take out an x squared out of each of those terms, which would leave me with nothing there. And x to the power 5 divided by x squared is going to be x cubed. Then I'm going to go to this term, and I can take out 6 of those guys. So maybe I'll use this little pen here to see that. These two guys, I can take out 6 of those. So that's why I have the 6. And when I do that, I'm going to be left with 1 left here and none over here. And then this guy here, I can take out 5 of these guys. So notice that I have a 5 right there, which would leave the x to the 6 plus 4 left over. And over here, I'm going to have none of those because I took out 5 of them. Okay, at this point now what I want to do is just collect all those like terms. So I'm going to expand out here and here. I'll expand out, I'll expand out. So when I do that, I get this, and then I'll look to collect like terms. If I can take any terms out of there, I will, but I can't. If there's a negative there, I take the negative out as well. But I hope you can see that that was pretty tricky. So let's take a look at this next one. So as differentiate, hopefully you can tell that this is going to be a quotient rule. So we want to be careful once again. So let's be careful. Let's call this F and let's call this G. And now we just need to fill it out. So here's F prime right here. Here's G. Here's F. This is G prime right there. And so here we go. The derivative of that top term is going to be 5x squared plus 5 to the power 4 multiplied by the derivative of x squared plus 5 multiplied by G. And this is F right here. And the derivative of x to the 6 plus 2 cubed is going to bring down the 3. 3 minus 2, 3 minus 1 is 2. And of course, the derivative of that is this guy right here. So once again, we need to be really careful here. We'll just sort of bring these terms to the front, bring those terms to the front. So let's see, we've got the 10x from the 5 and the 2x. We've got the 18 from the 3 and the 6 and the x to the 5. We're now going to take out common factors on the top, which I think I did. Yes, I did. I took the 2x. I took the 2x here, and that goes with the 5 and the 9. And then we took out an x, and that's why that x there is gone. So now I have no x terms left. This was x to the power 5, now it's x to the power 4. We are going to take out, let's see, we got that to the power 4 and that term to the power 5, so I can take x to the power 4 out of those, leaving me with the 1 right there. And then we got that guy to the power 3 and that guy to the power 2, so I can take x to the power 2 of those things out. That's why I have 3 there, and now I have 1 left. Notice that we took the two of those terms out. Then what we're going to do is we're going to collect all these terms, which was done right here. So I expanded, and now I'm going to collect like terms one more time. And then we'll have this. Notice right here that I have a negative there, so I'm going to take out that negative out in front. And when I do that, I will be done. And there you go. So clearly tricky question. I hope that helps you. Okay, explain 3 different ways to differentiate verbally. Okay, so I'm going to let's be able to talk about that. So this is this whole thing to the power 7. I want you to be able to clearly articulate 3 different ways to do this. So here are my thoughts. So step 1, of course, would be to say, I don't know, but let's take a look at part 1. So part 1 could look like this. You'd end up, pulling the 7 down, making that to the power 6. So that's why I have this business. And then I need to multiply it by the derivative of this term here. And so the derivative of this term here would basically be the quotient rule. So there's f, so the derivative of that is 2x times the bottom minus the top one times the derivative of that, which is 1. So one way would be the chain rule, and then take the derivative of this part, and this part would require you to take the quotient rule. So that's one way. Another way would have simply been to just, make this to the power 7, split it apart by exponent laws, and now we're very simply using the quotient rule. So it's going to be, there's f, there's g. So there's the derivative right there. Oops. Right there is, that right there is f prime. There's g, there's f, and there's g prime. Excuse me. Over g squared. So that's another option that you could certainly use. And the third one, which some of us might not think of, and I don't know that I would use the technique, but you should know it and be able to articulate it. What if we started the same way as we did with the quotient rule, but this time let's just pull this guy up. We're going to pull this guy up here and make that to the power -7, and now we can multiply that through using the product rule. So there's f prime, there is g right there, there's f, and there's g prime. Feel like something went wrong there. Something went wrong there. That is incorrect. So that should be, what did I forget? That's f, and we didn't get g prime at all. So that's just incorrect there. So that needs to be fixed, and we'll fix it before you see it. Okay. Well, last question, which is determine the equation of the tangent line to the curve y equals blah, blah, blah. And friends, we've done this so many times, so this is going to be a quick one. You're going to take the derivative. Remember, we're trying to find the tangent line, y equals mx plus b. When we look at it, sometimes it's helpful for you to see what it looks like in Desmos. So we'll look at that graph first, because you don't know what that graph looks like, and frankly, neither do I. There's the 0.380 right there, and we're wondering what the slope is right there. So let's get back to it. So what we're going to do is take the derivative here, and the derivative would be 30 x squared minus 7 to the power of 2. That's a 7 there. And then we're going to multiply it by 2x. That's the derivative. So of course, if we put in our 3 there, that's going to be 3 squared is 9 minus 7 squared multiplied by 6. And so we're going to have 30, and 9 minus 7 is 2. 2 squared is 4. And then we're multiplied by 6. We're getting close. 30 times 4 is 120, times 6 is 720. So that means that the slope of this line is going to be 720x plus b. And of course, if we take this 3 and put it in for x, and we take this 80 and put it in for y, we should be able to figure out what the y-intercept is. Let's go ahead and just do a little quick checkaroons and just see if we got that. Look at that, 720. And let's see if we can make any headway here. Bam, that's not going to move at all. So I can just make that 1,000, maybe 10,000, maybe 1,000, maybe negative 1,000, maybe 10,000. Make that a bit bigger. And when I do that, let's see. Look at that. That is certainly what we're looking for. My hand eye is going to be a bit shaky here. There you go, looking pretty dang good. So anyhow, the answer is the slope would be 720, as we said it was. So friends, I think we should leave it right there. Make sure you're making regular entries in your digital portfolio where you showcase your curricular competency skills and keep on growing. All right, chats.